Hey everybody, this is Mr. Beckstrom, and welcome to the last section of this book. This is 7.4 on amortized loans. And the first thing we're going to talk a little bit about is what is amortization. And that is basically usually used when we buy a house. So we buy a house, we take out a loan. They're going to calculate how much interest we should be paying on this loan over the set number of years. And then we're going to be paying a regular monthly payment until the principal and the interest is completely paid off. And the way the banks work is the first few years you're paying almost all interest on your house. That way, if you sell it, you have very, very little equity in it. Which means that you're not going to pay off the actual principal for many years. And then towards the end of the loan, the last 5 years of that 30-year loan, you're going to be paying almost all the principal. So that way it becomes better if you want to sell your house or something like that. All right, so let's take a look at this crazy formula here. So this is the principal times 1 plus the rate over the monthly or the payments per year, the number of payments per year times the total number of payments, and that's going to be equal to the monthly payment and all of this stuff here. So really this left side is just that compound interest formula that we've already learned in section 7.1. And the right side is the annuity formula that we just learned last month. So we can set these two equal to each other and we can solve for various variables in here. So let's take a look at an example. All right, this one says, assume that you have taken out an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18%, and you have agreed to pay off the loan in 4 years. What is your monthly payment? All right, well, let's go ahead and start going through these variables here, identifying them. All right, so the principal, that's the amount of your loan or the amount that you deposit, so that's going to be $10,000. And then we have the rate in decimal form, so 18%, so that's going to be 0.18. Just move that decimal place to the left. And then we have M, that's the number of periods per year or periods per year. In this case, remember that the compounding periods per year has to equal the monthly or the frequency of our payments. In this case, the payments are monthly. So M is going to be monthly, and there's 12 months in a year. So that's the number of compounding periods in the year. Remember, N is going to be equal to M times T. So that's going to be equal to 12 times the number of years, which is 4 years. And that's equal to 48. All right, and M, and I think we've got everything here. Oh, and then R, that's the monthly payment, and that's actually what we're going to be solving for. All right, so putting this in, I'm just going to kind of replace the variables here. So we're going to have the principal, 10,000, times 1 plus R over M. And let's go ahead and figure out that R over M here just to make it a little bit easier. So that's going to equal to 0.18 divided by 12. So pulling up my calculator. All right, 0.18 divided by 12. That's R over M. We're going to get 0.015. So 0.015. And that way we can just replace all 3 of our R over M's with that. 0.015. And this is going to be raised to the N power, 48. All right, and this is all equal to, I don't have enough time to put it on this, or enough space to put on the side, but R, which is the variable we're solving for, and then we're going to get 1 plus the r over m, 0.015, raised to the 48th power, minus 1, man, it's a lot of work, isn't it? All over 0.015. All right, so the idea here is that we're going to get a number on the left, and we're going to get r times some number on the right. And then all we have to do is divide both sides by the number on the right in order to solve for big R. So what I'm going to do is I'm going to first find out what this number on the right is. So let's do that now. So this is going to be 1.015. That's this part right here when you add them together. Raised to the 48th power. Enter. Then we're going to subtract 1. Enter. And divide by 0.015. Enter. And I'm going to get this value here, and I'm going to kind of write that there. So this is going to be 69.565. I'm going to go up pretty far. 565,219. All right. Now I'm going to find this side, and then I'm going to divide it by this side here. Now, if you have a TI-83 or TI-84 or a graphing calculator, I can actually take this value here, hit the Store As key, say X, enter, and now I have that number saved as X. So anytime I put the X in there, it's going to give me that number back. So now let's find the other side, which is 10, hold on, let me do this in the right order of operations, 1.015 raised to the 48th power, enter, and we're going to multiply that by 10,000, enter, and we get this number here. And then remember, the final answer, you just divide both sides by this number, so I'm going to divide by X, because I saved that number as X, and my answer is, my payment is going to be $293.75. That's not too bad. All right, let's take a look at another example here. And let's actually, this time, we'll just kind of make up a problem. And let's say we're buying a house. We're buying a house. And we'll use actual values, and we'll answer some questions about it. So we're buying a house. We're getting a 30-year mortgage. 30-year mortgage. All right. Oh my gosh, I can't spell. Oh, there we go. AGE. All right. And right now the interest rates, I think about the highest right now is about 5%. It's a 5% interest rate. And what else do we need? Oh, we needed the cost of the house. So right now houses are pretty high. So the average house, probably nice house around here, is probably about $350,000. So let's see, what is our monthly payment going to be? What's our monthly payment? Monthly payment. All right. And the other question I want to know is, how much am I going to be spending altogether on this $350,000 house? So some of you may have bought a house. Some of you are maybe thinking about it. Maybe some of you, it's a long-term goal for you, but this is how we figure out these questions. So let's put it in the formula here. So this is going to be the principal, which is $350,000. And you can start off by putting everything or identifying all the variables, but we just did that last time. So let's kind of jump right into this one plus, and this is going to be the interest in decimal form divided by the number of compounding periods per year, and it has to match our payment. So since it's monthly, that's there's 12 months in a year. We're going to raise this to the 12 times 30. That's going to be a big number here. So 12 times 30, remember that's M times T, so that's 360, and this is going to be equal to R times 1 plus 0.05 divided by 12 raised to the 360 minus 1 all over 0.05 divided by 12. All right, so let's go ahead and see how we can do it straight from this right here, not even figuring out what R over M is. So there's multiple ways to do it, and you want to find the way that works the best for you. So I'm going to start on this side again, and then I'm going to end up saving that number or writing it down. But this is going to be 1 plus, in parentheses, 0.05 divided by 12. So we start with this part right here. So enter. And then we're going to raise that to the 360. Enter. Minus 1. Enter. And finally, I can divide by 0.05 divided by 12. So divide by 0.05 over, or divided by 12. And make sure to put that in parentheses so it does it in the correct order of operations. You don't want it to multiply by the 0.05 first and then divide by 12. And so this is the number on the right. And I'm going to go ahead, either write that down or store it as X. And now we're going to get the number on the left here. So that's going to be 1 plus 0.05 divided by 12. Divided by 12. All right, and we're going to raise that to the 360. And then we're going to multiply that by the $350,000. All right, so that's a huge number there. And we're going to divide that by our X, or that number that we saved from earlier, because that's what we're dividing both sides by. And we can see that our monthly payment is going to be around $1,878.88. It's a pretty high payment, right, for a $350,000 house. So that kind of gives you an idea of what your monthly payment, and that's if you don't put any down payment at all. So this would be if you financed the entire house. And really, if we want to see how much we're paying total, you just take this monthly payment and you multiply it by the total number of payments that you're going to have for the house. So if you multiply that by 360, you're going to see that over the course of the 30 years, you're actually paying $676,395.25. And if you subtract out the amount of that loan, that means that you're paying over $326,000 in interest. So you're paying almost as much in interest as you did for the actual home. Banks make a lot of money off of you. All right, let's take a look at one more question here. Okay, this one here says, if you can afford to spend $200 each month on car payments, and the bank offers you a 4-year car loan with an annual rate of 12%, what is the present value of this annuity? And another way to say this is what price car can you afford? That's kind of what it's asking here. Is you can afford to spend $200 a month. You find a place that does 4-year car loans for 12% interest, and what is the maximum value of the car that you can buy? And that would really be kind of like either the loan amount, but it's P in this case. So let's go ahead and solve this one. So P is what we're going to be solving for. The rate is going to be 0.12, the 12% in decimal form. The M is going to be, we're making monthly payments, so the compounding periods have to equal that. So that's going to be 12. Oops. It's going to be 12. Let's go ahead and find R over M. R over M. And that's going to be 0.12 divided by 12. And I think that's going to be 0.001. Let me see. 0.12 divided by 12. 0.01. That's right. 0.01. And then we also have N. N, which is going to be M times T. So 12 times the number of years. And that's going to be equal to 48. And finally, we have R. Yes, that is our regular monthly payments, which they give us as 200. All right, so let's go ahead and plug this in here. So remember, I'm solving for P. So this is going to be 1 plus, and R over M is 0.01 raised to the 48th power. And that's going to be equal to R times 1 plus 0.01 raised to the 48th minus 1 all over 0.01. So in this case, I'm going to get a value here, and I'm also going to get a value here. And then if I divide both sides by this value, I will solve for P. So first I'm going to find this value and save it, and then I'll find this value, and then I'll divide this value by that value once again here. So if you do a little bit of forethought, you can save yourself a little bit of time on the calculator. All right, so I'm going to do the left side here first. So that's just going to be 1.01 raised to the 48th power. And I get 1.61, So let's go ahead and store that as our x again, or write it down. And then on the right side, I'm going to get 1.01 raised to the 48th. Enter. We're going to subtract 1, and then we're going to divide by 0.01. And I'm going to get 61, this whole number, and then remember I'm going to divide it by the left side number. So, and I stored that as my x there. So I'm going to get, oh, hold on, I messed up somewhere. Oh, I see exactly where I messed up here. So this R here is 200, and I didn't put that in there. So that should really be 200. 200. So, erase that there. We did solve for that. I just didn't put that in there. So let me go back and do this one here. That's 1.01 raised to the 48th power. Right? Yep. Minus 1 divided by 0.01 and times 200. That's going to give us a better answer. And then we're going to divide this side by that x that we had saved, which is this value here. And so the most expensive car that I can afford is around $7,594.79. All right, everybody, that's all I have for you. If you have any questions, please let me know, and I hope you have a great rest of your week. Thank you.